Everyone, can everyone hear me clearly? Yeah. Okay, so welcome to my session, building your first REST API in less than 30 minutes. This talk will form a beginner's talk to the Play framework. So if you're already an expert and want to stand up and walk out now, I won't be offended. But if you leave after that, I'll hate you the rest of my life. And this talk will also be a session where I'll show you on how easy and quickly you can develop applications using the Play framework. And I'll show you some cool tools if you want to prototype some stuff out that you will be able to use. But before I start, let me first introduce myself. My name is Meijers. I am a junior software developer at Lunatech. Lunatech is a software company based in Rotterdam, where we build mostly Scala applications using the Play framework and Akka. I'm also a student, where I'm currently pursuing a bachelor's degree in information technology. And in my spare time, I like to geek out and learn about stuff like functional programming and basically everything evolved around the web. So, what are we building today? We are building a simple REST API for managing your work hours. I always forget to fill in my work hours, so that will be a nice reminder for me. But for you, because you all know a bit of the domain, there will be a nice simple use case as an introduction to the Play framework. Now, the API will consist of 3 models, which we will be able to create, read, update, and delete. Now, I know that Jonas said yesterday that you shouldn't update and delete, so thanks for ruining my talk. But I'm going to do it anyway, because not everyone has unlimited disks to to supply. So, and the API will consist of 3 models. You have your employee, that's the one who does the work. Then you have the project, what's related to the time entry, so that your boss knows who to send the bill. And then you have the time entry, which is the actual work hours, where you have your start time, your end time, and it's linked to the project and the employee. And I already created these models into Postgres, so that you don't have to see me set up the boring stuff. But since we're building a REST API, let's have a quick REST refresher so that we all know a bit more of the theory again. So, as you probably all know, REST stands for Representational State Transfer. It was first mentioned by Roy Fielding in his dissertation paper for his PhD called Architectural Styles and the Design of Network-Based Software Architectures. And this paper was a big influence on the internet, but especially on web APIs. And out of this talk came like 6 constraints, which are now known as the 6 Fielding constraints. And if you want to call your web API a true REST API, you have to fulfill these constraints. So what are the constraints? First you have the client server. So this constraint is where you have a client that sends a request to the server either rejects or accepts the request, and if it accepts the request, then eventually it will send back a response. All pretty easy. And as a server, we'll be using the Play framework, and as a client, we don't really care about, someone else can implement that. I'll be using a simple Chrome plugin for testing purposes. And you have the second constraint, the statelessness constraint, and this is where your server shouldn't save any state of the client. So for instance, the client wants to retrieve some documents. It can say, give me the first 5 documents. And after that, if it would say, give me the next 5 documents, then the server wouldn't know where the client left off. And so you have to specify your starting and your ending points of how many documents you want to retrieve. And Play stateless is by default, so it makes it really easy for you to fulfill this constraint. Then you have the third constraint, the cacheable constraint, and this is where your server should be able to provide a client with a response header, for instance the e-tag, or the expiration header, on how long this certain representation is valid. And this way, if the client implements it well, it will save you quite a lot of data. And then you have the fourth constraint, the layered system constraint, and this is where the client has the feeling of only talking to one server. But for all you know, it's talking to an API gateway with 10 microservices behind there, or maybe you have multiple instances of Play running with a load distributor. But the client shouldn't know that. And then you have the fourth constraint, the uniform interface constraint. And the uniform interface constraint is all about rules. So where you get the most out of HTTP, so you use the right HTTP methods. For instance, when you want to retrieve something, you obviously use a GET. And when you want to create something, you use a POST. And you also give back the right responses. So in the case of when you create something, you give back a tool once created. another 200 OK. And this is also about hypermedia and linking between your documents. I won't go too much in detail about that, because let's keep things a bit practical. But we'll see some linkage in the API we're going to build. And then you have the last constraint, the code-on-demand constraint. And the code-on-demand constraint is where your server could send your client some pre-implemented features, so some code. And then the client doesn't have to implement everything themselves. And this is the only optional constraint, and since we have 30 minutes, we're going to skip this one. But before we start building, we need a database, and since I already put the data in the relational database, you have several choices for play. First off, you have Slick, probably the library created by TypeSafe, where you can query your database the same way like you would use Scala collections. And it's a really nice library, but it kind of has a steep learning curve. So we're going to skip that one. And then you have ANORM, and ANORM is like the closest to SQL, but I like a bit more of my auto-completion and to use functions. So then you come to a bit more or less unknown library, and it's called ScalikeJDBC. And I like ScalikeJDBC for several reasons. ScalikeJDBC is a tidy SQL-based database access library for Scala. And it's basically a wrapper around the JDBC APIs. And it's a really easy library to use. It has great documentation. Within an hour of reading their websites, you'll be able to use this library, and it's very simple. They also have active development, so that's very nice. With the Play framing support, 2 weeks ago, Play 2.4 came out, and straight away they had their module ready, because Play switched from plugins to modules. And so that's very nice, so you can keep using your favorite tools, and even when new versions come out. And if you want to query your database using their query DSL, you have to create a mapping. And for instance, we have this time entry case class. That's like the case class we're going to use to create, read, update, and delete in the demo. And what you want to do if you want to retrieve this from the database and create new entities in the database, then you need to create a mapping. And you do that in the companion object. And you first have to extend the SQL syntax support trait. And then you have to override some values like the table name and the columns. And then you have to also supply with some syntax that you will be able to use in your functions. And you have to create 2 apply methods so that ScalikeJDBC knows how to create your SQL results into actual objects of your case classes. All pretty simple. And that will allow you to write functions like these. For instance, the find function, where you put your query between the with SQL braces. And then this is a simple where equal. And then if you have the result, you map over it and you apply that result to the apply method you defined earlier. And then if you want a single resource back, you specify the single. And in the case of a list, then you say the list. And ScalikeJDBC also has some nice options where it takes care of some optional values, for instance, with the to and condition opt. So all pretty simple, but still very nice and really easy to use. But creating those mappings, that's a lot of work. And functional programmers don't only like to evaluate lazy, but especially in my case, sometimes I am a bit lazy. So let's auto-generate those. And especially with prototyping, that's nice because you have results pretty quickly. And the guys from ScalikeJDBC created an awesome SBT plugin for that, called the reverse engineering. And you use the SBT in your terminal, and then the command ScalikeJDBC gen with the name of your table, and then the case class or the normal class that you want it to be mapped to. So, like Torvald said, talk is cheap, show me the code. Let's start by building the actual web API. So normally when you create a Play application, you use the activator. That's like the platform around TypeSafe to create new applications and even a lot more. And I already did that so that you don't have to see me set up the database, and that way I already have my library dependency so that I don't have to trust the Wi-Fi here. And in a normal Play, application, your app looks something like this. You have the app folder. Play works with the model view controller architectural pattern. So in a simple application, you would have here a folder with your controllers, your models, and your views. But since we're creating a web API, we won't have any views, but we create the JSON representations in our controllers. And then you have another directory, the conf directory, and this is where obviously all your configuration goes into. Your application.conf, this is where you specify, for instance, your database connection, but also where you enable new modules. And then you have your routes file, and your routes file is like where you link your unique resource identifiers, so your URIs, to your actual controller methods. And you do this by first defining the HTTP method, after that the unique resource identifier, and then the link to the controller method that you want Play to use. And you can also have dynamic parts in there, for instance here with the ID that then Play will provide as an argument to your controller method. And then you also have the project folder, and the project folder is where your plugin.sbt is. So this is where I had to add the reverse engineering tool from ScalikeJDBC, and I also had to create a little file to tell SBT how it can get to my database. And then you have a test folder, and this is where all your tests goes into. And then you have build.sbt, and this is where your library dependencies, where you manage your library dependencies and stuff like your Scala version. So as you can see in the app folder, we don't have a package of models yet. So let's start by reverse engineering them. Here in my console, I'm in the root directory of my Play application. So here I can type ScalikeJDBC, SBT, ScalikeJDBC gen, and then the table name, and then the name of the case class I want to be generated. And this is a really nice tool for prototyping, because it will probably do most of the work for you if you want to get something done quickly. So as you can see here, the models.time entry is created, and the models.time entry spec is created. Now let's do the same for the employee and the project. So what ScalikeJDBC will do, it will look at your database schema, and from there on it knows how to map to it. So for instance, if you have like a column that's nullable, then that will turn into an optional value. Oh, I pressed enter again. It will already exist. And then the project. So there the project is also created, so now we have our model classes. So I'm going to type activator run to run the application, and then we can start building, and Play it can automatically compile where your server is running, so you don't have to start and stop it the whole time. So let me switch to IntelliJ. As you can see here, the models are now created. So let me show you the time entry. And there you have the case class from your table. It's also created a function, a method for save and destroy, so that when you have the actual object, you can save and destroy it. It's created a companion object with the mapping all for you. And it's created even some functions like a find function, the find all function, the find all by, and the create, save, and destroy methods. So that way you don't, so we basically now have everything we want to be able to make that create, read, update, and delete API. And since we want to, represent this time entry as a JSON representation, what might be a good idea is not to directly link it to your case class that talks to your database, but put a layer in between there so that you don't, so that everything is not so well connected to each other, and you can still change your actual case class if you want that. So let's create another class called time entry data, and I already copied this one. No, that's not it. I already copied it so that we don't have to create it all. And what I basically did is exactly the same class as the time entry, except I didn't show the ID there because that's of no value to your representation. And then I also created the create function and the update function, which uses the functions created by ScalikeJDBC to create and save these time entries. Now, if you want to create this into a JSON representation, you have to use what Play calls implicit reads and writes. And that's what I do here. And basically with this line, with the JSON.reads from the JSON library, and you specify your type there, now Play will know how to convert this case class, in this case with the reads, it knows how to get the JSON and turn it into a case class. And with this one, it knows how to write that object to a JSON representation. So that's basically all the code you need. And what's also nice about this extra layer is if you have multiple apply methods, you can't do a simple function like this, then you really have to define a mapping, otherwise Play won't know which apply methods to use. And then the last function I created was the from-time entry, where you have a time entry that as an argument, and basically this will enable you to switch easily between the time entry and the time entry data. So that's all the model classes we need. So if I go to my roots file, let's start by implementing the API entry point or your index, which is the /API, and I linked that to my controller's application.index. So let me go to the function. And creating controller methods in Play is all about the action trait, and the action trait has an apply function that takes a partially applied function, where you have a request that gets turned into a result, so that looks a bit like this. Requests, and that gets turned into results. So that will be part of your action. And because you will be using that request quite a lot, most of the time you want to define it implicitly, so that you don't have to use it every time when you're, because a lot of Play functions actually use that request. And since we're building a JSON representation, let's create a val in JSON. And with the JSON library, you have an object method there that takes maps, and then you can create JSON out of that. So let's create a value called version, and then with the version of 0.1, because this is like the prototype of the prototypes. And then you want to create some links to the other resources from your API. So we can create a sequence here, and Play will create this into a JSON array. And then you pass in here another JSON object, with your rel pointing to the time entries, and then an href pointing to the time entries unique resource identifier. Now if you want, because the roots file gets compiled, you can actually refer to this using a function, and then this way if you change up your URIs, not your whole application will break. And you do this by using the roots object, and then the time entries, and the first controller method we are going to implement is the get time entries, and this will get like a collection and show it to the client. So let's try and check this out. I'm sending now a request. Play normally runs on localhost 9000, so I'm sending a request to the /API. And straight away a compilation. Oh, that's because I didn't make it into an absolute URL. You get back a call object from that, and if you want to make it into a JSON representation, you have to make it into an absolute URL. And of course, I also need to give back a response. And you do that by using the response methods. So in this case, you want to give back an OK JSON, but for every type of response, you have one of these methods, for instance, batch request, stuff like that. And then you build a response out of that request that will later be added by Play. So hopefully when I send a request now, it will compile. And there you have it. Your API entry point. So let me zoom in a little bit. And there you have your version and the links that points to the array of JSON objects with the href pointing to the time entries. Now if you look at the headers, you don't see an e tag here or it expires, and this is like the perfect use case to cache your responses. And in Play that's really easy. Since Play 2.4, Play uses dependency injection, so you have to inject an object called the cached object, and it's like a helper object for you to easily cache responses. So then you use the cached object, and it has a function status where you have to supply a key. So let's call it index. And then you have to give back your status, so in this case a 200 OK, and then the time you want to be cached. and you wrap this around your action. And now Play will only cache the status when it's a 200 OK. So let's send another request. So now you can see that the headers also have an E tag and expires. So that's really easy. And now let's start with implementing the time entries collection. And that's in the time entries controller class. Play uses now classes instead of objects. That also has to do with the dependency injection. So let's start with the action again and the implicit request. And let's first get all the time entries. So create a value time entries, and then the time entry.findAll, which is like the method that ScalikeJDBC created. And then you want to turn this into JSON representation. So let's make a JSON object time entries, which points to then the JSON objects. But we first have to map over the time entries to create this in actual time entry data and then to a JSON value. So then we create a value time entry data, and then we can use the time entry data and then the from time entry where we pass in the time entry, and now we have the time entry data. And then we can use the JSON to JSON method, and that will create that will look in the companion object of the time entry data, and then it will create a JSON representation out of that. And then let's give back the result with the 200 OK with the JSON in it. So let's send a request to there. And there you have your time entries with all the representation. But now it's not linking to each individual resource, and of course we want that as well. So let's add that as well. I created a little function called addSelfLink that will add a self-link to the JSON object. And you have to do the reverse routing to the individual object. So that's the get time entry. Oh. And then you have to pass the time entry ID in there. And that's like the next controller method we will implement. And let me show you the addSelfLink. That's from the JSON utils trait I created. And there you have a JSON value, which was in this case the time entry data. And then your call. You have to downcast that JSON value into a JSON object. And then you can add another JSON object, which in this case is the link pointing to itself with the absolute URL of the call you passed in. So let's send another request and see if we now also have links to individual resources, and we do. So let's start by implementing that. So you start off again with the action and the implicit request. And then we first want to find an individual time entry. So this is you can use the find method that's created by the ScalikeJDBC reverse engineering tool. And then you get back an option, so you can pattern match over that. And in case of some time entry, we want to do something. And in case of none, we give back a not found with a JSON object in there with an error message saying, for instance, not found. And when we have the actual time entry, we first want to create it into a time entry data. And we do that by using the time entry data companion object with the from time entry method. And then you want to create a JSON representation out of that. So let's add the self-link and the JSON to JSON method, where we pass in that time entry data. And then again the call to the roots. So in this case, that's the get time entry with the ID. And once you created that JSON representation, you want to give it back as an OK with the JSON in it. So now if I send a request to the time entries /1, this will give me back then the individual time entry. And if I request one that doesn't exist, for instance, the time entry is 100, that's not, I didn't go that far in my dummy data, and then you get back the 404 not found. So we also want to create time entries, and you do this if you have an action and you want it to only accept one certain type of JSON, so in this case the application /JSON, and you want the body to be parsed already, you can use the parse JSON. And then you use your implicit request again, and then from that request you can get the body, And that will be a JSON value, and you can validate that in the object you want it to be. So in this case, we want it to be a time entry data. And this can go either wrong or right, so then you can fold over it. And in case of an error, we send back a batch request with the JSON object in it, saying error, and then JSON was not correct. And in case when it went right, you get the actual time entry data. So then we can use the function, oh, I have to make it into an arrow. And then we can make the actual time entry from the time entry data .create function that we defined earlier that uses that function which was created by ScalikeJDBC. And then you can give back a created, and you can add headers to your response using the withHeaders function. And that takes a map, so in this case we want it to point to the new location. So then you use location and then the reverse routes again, pointing to that individual resource. And of course you want to make that into an absolute URL. So that's all you need to create it. I already made a little post for time entries where you have an employee ID of 2 and a project ID of 2 and a start time and an end time. So let's send that to play. Now you can see the 201 created with a header, in this case the location header, pointing to the new created time entry. And we also want to edit time entries. And that's basically exactly the same as creating a time entry, but then once you have the actual time entry data, you first want to make sure that it actually exists. So we'll be using the time entry .find method on the ID, and that gives back that option where we can match on. So in this case, some time entry. And in case of none, we can give back the not found. So let me copy that. And when you have an actual time entry, you can use the time entry data.update, and then you can use the time entry that you found, the ID, to specify which row it needs to update. And then you can basically give back a no content telling the client that everything went all right. So let's edit the time entry. Here I have time entry 15. Let me first get that. And Blade needs to compile. And then you can see in the body that it now has an employee ID of 2 and a project ID of 1. But I made a little mistake and I want to change it into employee ID of 3 and a project ID of 2. So let's send it to play. Then you get back to the 204 no content. And if we send another request to that, you have the start time, you have the employee ID that has been changed and the project ID that has been changed. So that's fairly simple. Now you also want to delete time entries. So let's start off with the action and the implicit request again. And first we want to find the time entry. So we use that ID, and since there are probably some people out here who don't like pattern matching that much, let's map over it. And then we can say the time entry and we can destroy it. And then we can give back a no content saying that everything went all right. And if it didn't get found, then we can do the get or else on the map and give back the not found again. So let's say we want to delete time entry 3. So let me first get that to check if it actually exists. And it exists, and we messed it up so badly that we just want to delete it. So let's delete it, and then you get back the 204 no content. And if you send another request, it will give you back the 404 not found with the JSON error message. So that's basically create, read, update, and delete. And since I have some time left, I will create another controller method. So let's go to the routes file, and let's say your boss wants to check up on you if you actually did all the work you were supposed to do that week. So let's get all the time entries from a specific employee. So you start off by using a get, and then the /API/employees. Then the ID of the employee you want to check, and then the time entries, because you want to retrieve those time entries. And then I have to create a controller method in the employees class, and let's say get time entries. And then the ID which is the employee ID. Let's create that. And let's start off with the action and the implicit request again. Let's first find all the time entries. And in this case, we can't use the find all, but you have the find all by function. And this is where you can specify then your where clause that you can finish. So in this case, you want to use the equals object of ScalikeJDBC and then the equal version. And in this case, we want the time entry and then the employee ID to be equal to the ID of the argument of the controller method. And then we have our time entries of that specific employee. And then we want to create it into JSON again. So let's create a JSON object with the time entries pointing to the time entries JSON representation. So we have to map over that again. And then you want to create it again into the time entry data. And then the time entry data dot from time entry. Let's pass a time entry in there. And then the add self link. And then the JSON to JSON method with the time entry data. And then the routes.time entries to link to that individual resource. So that's the get time entry that we implemented earlier. And now you want to give this back as an OK. So let's fill the JSON in there. And then if I go to my routes file, let me check that URI again. And let's check out if it actually works. So let me pass that in there. It needs to be a get. And then let's say we want to get all the time entries from the employee with an ID of 1. And there you have it. As you can see, now the time entries only appear from the employee with an ID of 1. All pretty simple. So let me go back to the slides. And let's check out the fielding constraints on how we did with building our first REST API. So we have the client server. We use the server as a play framework. Pretty simple. The communication was one-on-one. Then you have the statelessness constraint. We didn't save any state of the client. So that was also pretty simple. And then we cached our API entry points to the client. So we fulfilled that constraint as well. The layered system, we didn't have really anything to do with that, but still the communication was there also one-on-one. And then the uniform interface, we used to write HTTP methods, we used to write responses, and we even had some linkage in our documents. And the code on demand is the one we skipped. So if you want to see the finished project with the other 2 controller methods, you can check it out on my GitHub. My username is Thomas Meijers, and then under the repo is Scala Days 2015 example REST API. And because, it was a bit quick and a bit dirty, and that wasn't really how you want to do it in production, but as a prototype, that's fine. And I now have some recommendations where you want to improve on. So since we were using the ScalikeJDBC, and that was like, that's a wrapper around the JDBC API, your database calls are blocking, and you want those to be asynchronous. Now, ScalikeJDBC actually made a library called ScalikeJDBC Async, which is still an alpha version, but sadly you don't have the reverse engineering tool there, so we couldn't use that one. And James Ward wrote a really nice blog post about that library called Reactive Postgres with Play Framework and ScalikeJDBC. So if you're interested in that, I'll recommend you check it out. And of course, you could also use a NoSQL database. And we used our application/JSON, and what does that really say to the clients about your representation? They still have to read the whole documentation. So you're better off using a Hypermedia format, like HAL or Siren, and there are actually some projects on Scala which will provide you a library, also with Play support, that will make it really easy for you to create those representations. And then if you want to create some documentation, you can check out the swagger.ui, which there's also a Play plugin for. And then you can use annotations around your controller methods to create your documentation, and it will auto-generate that for you. And you can also use the swagger.io website to design some nice representation. So thank you for your attention. I hope it was a nice introduction for you to the Play framework. And if there are any questions, You can ask them now. I think we still have a few minutes left. So, any questions?
Yeah, I have one question. Maybe it's a silly one, but is there any option to return, instead of having to say time not found 404 and the message, is there any way to reduce that to return something else in case that every time it's a get and it's not found or an optional, you can wrap it up in something else so you don't have to repeat the 404 error message? You know what I mean?
Yeah. Yeah, you could probably write a function about that. I don't know straight away from my head how you would do that. But especially with the JSON objects you created, you can of course just write a simple function for that so that you don't have to create the JSON object all the time. I'll just try to show that now so that you get a little bit of the feeling of the JSON library. But you can actually use also action composition. And this is where you use the action to create those results. And there you can probably abstract of when you don't find something if you want that for specific controller methods. But that's only then if that really would be the same in every controller method. And that's called action composition. There's a no, you would do that. It's like an abstraction over your action, and then you create like a sort of new action that will already do something for you. But that's then the same case with every action that you provided then. So then you wouldn't say like your controller method an action, but then you would say, for instance, custom action, and then you would supply the request and then the result. So you could have a look at that. Any other questions?
What about testing?
Tasty?
Testing this
Oh.
project, so you didn't mention anything about testing. It's a prototype project.
Yeah. Actually,
What would you advise on that?
yeah, so ScalikeJDBC actually creates some tests as well. Since Play 2.4, I didn't get them to work so quickly. But if you look at if you have a look at the test folder, there you can see there the models with the created tests. But you have to add some stuff to make it work. And for your testing your controllers, yeah, you could just test that like you normally would. So that's not really anything specific. So yeah, ScalikeJDBC generates this for you, and this is like only for the model classes. So then with your controller methods, you still have to do that by hand.
ScalikeJDBC do with a rich main model? So now I noticed you've got all these really record-like structures.
Yep.
So what if you want the relationships then?
Yeah, if you have the relationships, then you still need to specify. The reverse engineering tool won't do that for you. But then you can simply, in the apply methods, you can make sure that it will also then it will retrieve that ID from the database. For instance, if you want to put a link between there, and then you can get those resources as well. So then you would specify it, for instance, where you have a time entry where there's an employee actually in there, so you want that model in there. Then you could say in the apply method, so also find the employee, and then you can use that ID instead of just giving back the ID. You would have to write a join yourself for that, yeah.
Oh, I see that generated tests. What if I use a different testing framework? Is there a way?
Oh, yeah, you can specify that in the ScalikeJDBC.properties. In your properties file, you can say here which testing template you want to use. Any other questions? So, thank you again.